So a couple of things you may have done already for other classes. I'm just going to show them to you for this class. If you go into our week 10 schedule folder and click on the page for our week 10 schedule, there is at the top right here a student engagement form for trimester 1. You need to fill it out once, and that information is being collected by Mr. Van Hefty and the PBIS team, to kind of give teachers an idea as to what's working and what's not working for classes that are being done online. And then you can see there's our schedule for the week is up and going. I just need to add what the assignments are, although they are also in the folder for chapter 8. So that's one thing. Other things that are of interest, maybe, excuse me. Next week, we will not have class over Zoom. It's a completely distant learning week. So there'll be an assignment pushed out on Monday. You'll have Monday and Tuesday to work on it. Wednesday will still be the typical Wednesday where if you need help, if you have questions, I will have office hours. You can certainly request a time and we can meet to answer any questions. Does that make sense? I will take that to mean yes. One other thing, if you go on the bottom of your Zoom meeting, there should be a tab called Participants. And if you click on that, at the bottom of that Participants menu, there are things like you could click for a yes or no, or go slower or faster. And then there are some more things like a thumbs down, thumbs up, clapping hand, need a break. If you need a break during this class, you're in trouble. And then away. So, if you need to use the restroom, rather than, messaging me and saying, "Oh, Mr. Gingrich, I need to go to the bathroom," just click the away icon, and I'll just see it kind of pop up next to your name in the participants menu. And then once you come back, click on it again and it goes away. So, excuse me. That way you're not, I think it'll just be easier than trying to message me and say, "Hey, I've got to go use the restroom," or I need to go get something to drink. I just think that'll work a lot better. All right. So yesterday we talked about the functions x, 1 over x, and x to the n power. And we talked about how x to the n, if n was even, we had the parabola shape. And if it was odd, it was that kind of S shape. And the larger the value, the more spread out that parabola or S shape becomes. Today, we're going to talk about square root function and absolute value function. Absolute value, I think, back in intermediate algebra was where we started with graphing. So hopefully that's a lot of review. And we'll kind of compare the square root function and x to the n when n is like x squared because there are a lot of similarities between the two. All right, and away we go. So we're just going to start with the square root of x. Where is it increasing? Where is it decreasing? Minimum value, maximum value, x-intercept, y-intercept, domain, range, and symmetry. So again, I'm probably doing this backward, but for me, it's always helpful to graph it first. And I think for most of these functions, you already have graphed them and know what the graph looks like. If not, you certainly can just pick some values. Again, if you're going to pick values, I would always start like in this case where whatever's under the radical is 0. So I would start at 0, and the square root of 0 is 0. So there's one of my points. And then for square root, we talked yesterday how the x squared function had that step pattern: over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7, and so on. The square root function is exactly the opposite. We go over 1, up 1, over 3, up 1, over 5, up 1. And we get that graph. All right, so let's answer some of these questions. Where is this function increasing? For what values of x is it increasing?
Increasing everywhere.
Yeah, so we want to be really careful though, because it's only defined, and this will help us with domain as well, but it's only defined for 0 and values above. So we just want to be careful with that. Don't say all real numbers, right? So we would say from 0, whoops, that 0 didn't turn out well. Try it again. And you could use the square bracket on the 0. There are some math books that say use the square bracket, include 0. Others say don't. Either way is fine for me. I typically use the parenthesis because I think, well, at 0, we're just starting. We're not increasing yet. What about decreasing? And Emma, you kind of, I guess, alluded to it when you said that it was increasing for everywhere that it was defined. That means it's decreasing nowhere. All right. Does this have a maximum value?
Will it be infinity?
Again, it goes off to infinity. It doesn't ever reach a number as a highest number. So we would say that there is none or no maximum. And then we have minimum value.
Is it 0?
Yeah. So the minimum occurs at 0, 0. So one thing with this, maximums and minimums, the x coordinate is where it occurs. The y coordinate is either the minimum or maximum value. Intercepts. Where does it cross the x-axis?
At 0.
0, 0. And how about the y-intercept?
Same thing.
Yep, same thing, 0, 0. So we know if we get one of the intercepts at 0, 0, the other one is also going to be at 0, 0. Domain. Again, we use set builder notation. All x values such that. So what x values can I plug in?
Anything at 0 and greater than 0.
Got it. X is going to be greater than or equal to 0. And the range all values y such that
Is it greater than or equal to 0 again?
yes. So here's kind of the thing with range. If we have a minimum, that means y is going to have to be greater than or equal to that minimum. If we have a maximum, y would have to be less than or equal to the maximum. And if we have both, then y sits right in between them, which is kind of nice. We'll see the example of both actually tomorrow. All right, something to look forward to for, okay, not tomorrow, Thursday. No new lesson tomorrow. Is there any symmetry?
No.
No symmetry. And so that's the square root of x. A couple of other things, and I think I mentioned it yesterday. If not, I should have. The domain and range on functions can change if we end up adding or subtracting things to the function. If you remember from intermediate algebra, adding and subtracting can either shift a graph up or down or left and right, depending upon where we're doing the adding or subtracting. All right, so that's the square root of x. The other one we're going to look at today is the absolute value of x. All right. So what was the most important part of graphing absolute value? What was that most important point called? Do you remember? Vertex. Vertex is the that point where the point goes. With absolute value of x, where is the vertex?
That's 0.
Yep, right at the origin, 0, 0. And then again, when I taught this lesson to intermediate algebra students, we always talked about kind of a slope idea. And if there's no number in front of the absolute value, we go over 1, up 1 as many times as we want to both the right and the left. And that looks really bad. Try that again. That looks better. All right, so as I move from left to right, where is this function increasing? For what values of x is it increasing?
Increasing above 0.
0 all the way to infinity. Decreasing.
Would it be infinity to 0?
And negative infinity to 0. That's exactly right. Do we have a maximum value? Is there a largest values of Mr. Gingrich? If we get to 500, that's the biggest.
No.
Nope. No maximum. Do we have a minimum?
Would be 0, 0.
Yep. Where do we cross the x-axis?
Zero, 0.
0, 0.
And
And
same
so we
for the
kn-
y.
Yep, same for the y. So again, if 0, 0 is an x-intercept, it will also be the y-intercept. There could be other x-intercepts, and again, we'll talk about that a little bit on Thursday with the functions we're going to talk about then. The domain.
X is greater than or equal to 0.
That will be our range. Our range will be all y values such that y is greater than or equal to 0. Gonna take a guess at the domain now?
The domain is all values then.
Yeah, all real numbers. And is there symmetry?
Across the x-axis
Ooh, almost.
or y-axis.
Yeah. So for symmetry, And so that's an even function. All right. Next. Just a few square root and absolute value functions for you to graph. Hopefully it'll be nice, easy, short work for you. Yeah, all the problems are on 386. So that's where we're at.